excuse me. In this video, we're going to look at the area between two curves and the area shared by two curves. These start to get a little bit more fascinating as we do them. Area between the two curves, we're going to remember what we did back in Calculus AB, and we're going to use that same principle, that the area between two curves is going to be the top curve minus the bottom curve, or the right curve minus the left curve. The only difference is that since it's all in theta, we don't have to worry about it if it's in terms of x or terms of y. But it's top curve minus bottom curve, right curve minus left curve. The area shared by two curves, that's where it gets a little hinky. But basically, you have to divide the area into two regions and see how the regions are defined by the radial line. That was a little bit more difficult, but we're going to do a couple examples with it. Okay, so we're going to start by finding the easier one inside one curve and outside the other curve, or in other words, the area between two curves. Once again, we're going to need our polar graphic skills in order to do this. What we notice is that we have two curves, r is equal to 3 cosine theta, and outside the curve, r equals 2 minus cosine theta. So we have to figure out which one is which. r equals 3 cosine theta is a circle symmetrical to the x-axis. We know that because it's 3 cosine theta, that we know that the diameter is 3 and that it is adjacent to the y-axis. So I know that this red curve, this red circle, is 3 cosine theta. I know because this is 2 minus cosine theta that it's a limation, that it's symmetrical to the x-axis, and because of the minus, most of the area is going to be to the left of the y-axis. So I know that this one is 2 minus cosine theta. Now they're not drawn to scale because that's not important. We just need to be able to recognize which is which. So we're looking for the area inside this curve but outside this curve. So that area would be inside the red circle, outside the black circle. So that would be this area. Inside the red circle, but outside the black circle. Okay? So how do we find that? Well, with anything, we need to find our radial lines. And we see that they intersect at this point. Okay? So that is their point of intersection. So if I can find that point of intersection, I can integrate from there to there. Well, how do you think we find that point of intersection? We're going to do the same thing we did in Unit 6. We're going to set these two graphs equal to each other. So we have 3 cosine theta is equal to 2 minus cosine theta. So that gives me 4 cosine theta is equal to 2, and cosine theta is equal to 1/2. Using my skills, my pre-calc skills, I know that theta then is equal to pi over 3. It's also equal to what? Cosine theta would equal to pi over 3, and it's positive down here, so like, what is that, 7 pi over 3, I think, pi over 3, 5 pi over 3, 7 pi over 3, 11 pi over 3. So why don't I use 11 pi over 3? Well, if I did 11 pi over 3 to pi over 3, that would actually take me around this circle. It would take me this way. Okay? So I want to go from here around this way. I want to go clockwise. Okay? So to do that, I'm going to have to go from negative pi over 3 to pi over 3. Okay? And then it's going to be right circle minus left circle. So my right circle is 3 cosine theta squared minus 2 minus cosine theta quantity squared. Now, if I were doing this by hand, I would make my life easier by integrating why did I do pi over 2? I keep writing pi over 2. That should be pi over 3, sorry. I would make my life easier by going from 0 to pi over 3 and then multiplying it by 2. But since I'm going to use my calculator anyway, what the hey, okay? So what you want to do is, again, you want to make sure your calculator is in radian and polar mode, and you want to put R1. You want to make R1 3 cosine theta. You want to make R2 2 minus cosine theta. And then what you want to do on your calculator is you want to integrate to 0.5 or 1/2, whichever you like, negative pi over 3 to pi over 3. And then remember, it's R squared, R1 squared, minus R2 squared d theta in your calculator. And your calculator is going to be very nice and spit out an answer, which is approximately, well, it is exactly 3 radical 3. But your calculator, unless you have a TI-89, will tell you it's 5.196. Okay? So what you had to know here is that you draw your radial lines, you find your point of intersection by setting them equal to each other, and then you integrate from that radial line doing top curve, right curve minus left curve, or if it had been the other way around, top minus bottom. Okay? Once again, we're finding, well, this one is different because now we're finding the common interior. And this is where it gets a little hinky. Now, other books will show you this differently, and that's fine, but I have to do it the way that makes sense to me, okay? So what makes sense to me is that I'm going to draw my radial lines. So we see we have these radial lines. Where are they? Lines. Okay? Apparently that's not it. Oh, here they are. Sorry. Cancel. Okay. So my radial lines go from my pole to this point of intersection. Okay? So we come here. La 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 la. Okay. Now, what I want you to notice, I still have to find these point of intersection. But notice how my area is now defined. This area above my radial lines is only defined by the green circle. It is the top of that green circle. But if I just got the top of that green circle, I'm still missing part of my graph. So I have to come back and get that bottom part of my graph, which is defined by the red circle. Okay? So I have to find those two different areas. So to find the green area, or the bluish green area, let's get that bluish green so you'll know which one I'm talking about. So to find this bluish green area, what I am looking at, well, first of all, I have to find this points of intersection. So to find the points of intersection, I have to do 2 is equal to 4 sine theta, which gives me 1/2 is equal to sine theta, which gives me pi over 6 and 5 pi over 6. And that makes sense because this is pi over 6, this is 5 pi over 6. So that makes sense that I am integrating from pi over 6 to 5 pi over 6. So the area defined by this green is 1/2 the integral from pi over 6 to 5 pi over 6. And it's being defined by that green circle. Well, that green circle is 2 squared. Now I have to find the remaining part of that. I have to find the area defined by that orange part of that circle. So to find what's defined by that orange part of the circle, I have to once again do 1/2 the integral. Now this is going from 0 to pi over 6, and it's only defined by that red circle. So I'm going from 0 to pi over 6, and it's only defined, this area is only defined by that red circle, so that would be 4 sine theta. Now, notice then I have to find from 5 pi over 6 to 0. What's an easier way of doing that? Well, these two sides should be symmetrical, so I'm just going to multiply this by 2 and only do it once. So when I'm done, my answer is the sum of these two areas. So what I get is this is 4.1887. And this one is 0.72. We would expect that to be much smaller than the other one. And these together give me a total area of 4.9134. And that's my final answer. Okay, this is similar to the one that we did before. We have inside of one area and outside the other one. Let's see what this is. I'm sorry if that's cut off. It's r is equal to 3 sine theta and r is equal to 1 plus sine theta. So once again, I'm going to find my lines of intersection. Okay, and I'm finding inside of r3 sine theta, which r3 sine theta is the circle on top, and outside the limachon, so outside the green. So that area is defined by this pretty pink area here. That's more like a mauve, but it's pretty. So it's defined by this area. So now we're going to do top minus bottom. So we're going to look at top minus bottom. So we are integrating we got to find our points of intersection. So I have to do, I think that is 3 sine theta is equal to 1 plus sine theta. So I get 2 sine theta is equal to 1. Sine theta is equal to 1/2. So theta is once again equal to pi over 6 and 5 pi over 6. So I'm going to integrate from pi over 6 to 5 pi over 6. And it's going to be top curve, which the top curve is 3 sine theta. Minus the bottom curve. Now, we're going to do this on our calculator, so it doesn't matter, but the College Board loves symmetry. So they could write this as and say, which of the following integrals give us the area, and write it from pi over 6 to pi over 2, multiplying everything by 2. Sorry, I got that square there. And giving us 3 sine squared theta minus 1 plus sine theta squared d theta. And again, the best way of doing this is to put this in R1, this in R2, and then on your calculator do R1 squared minus R2 squared, and the answer for that is pi. Okay? Now this is actually on the last page of your notes in the quiz review. I think it's probably number 16. But I wanted to do another one where it was shared by an area. Okay? So, and I didn't tell you the equation for this, but it's a circle centered at the origin with a radius of 2. So the equation for this would be r equals 2. And that's what we have here. That's the red circle. So we set those two equal to each other. We divide both sides by 2, and we get 1 minus cosine theta is equal to 0. So we get cosine theta is equal to 1, and cosine theta is equal to 1 at pi over 2. Now, looking at this, I can kind of tell that this is going to be both pi over 2 and 3 pi over 2. Okay? But when I go from pi over 2 to 3 pi over 2, again, it's how I'm sweeping. So I'm sweeping, get a different color so you can see. Let me get the yellow, that'll be good. I am sweeping this way. I am going this way. And because I'm sweeping this way, my integral will be set up from pi over 2 to 3 pi over 2. And I'm using the red circle only. Now, just FYI, I didn't have to really take an integral to find this area of that circle. I could have just used area of a circle is 1/2 pi r squared. And that should be equivalent to this. My next area, let's use something, a different color. Let's do pink. That's going to be too close to that red. Let's do white. Maybe that'll show up. Okay, so now to get this area, I'm sweeping in this direction to get this area, to get this part of the red. Because I want the area shared by the 2, I'm sweeping this way to get this limachan, to get the rest of the area of this limachan. Let's see if I can't make that nicer. Maybe I can't. Close. I don't want that. I want to do this. Sorry. I want a pen. I want to highlight it. So what I'm getting now is this area. This is what I'm looking for. Because it's find the area shared by the circle and the cardioid. So that is this combined area. Okay? So when I go from pi over 2, I get the area to the left of the y-axis. When I go this way, I'm sweeping this way, I'm getting the rest of it. I'm getting this gray portion here. I'm getting this portion. Okay? And so to do that, because I'm sweeping from bottom to top, I actually have to change my limits. And so now my limits are going to be from negative pi over 2 to pi over 2. And now I'm getting the limachan, which is 2, 1 minus cosine theta, quantity squared. So I have to get both of those in order to get the correct answer. And what I find is that that answer is 7.707. Because this one is 1.4247. And this is, actually I had that backwards. That's this one, 1.4247. And the circle is pi r squared, so the circle is 2 pi. So this is 2 pi, which 2 pi is about, what, 6.283? And those two together gives me 7.707. Okay? Let's do another one. Okay, so now we're going to find the inner loop. I'm going to pause this and I'm going to do this in video 3.